Hi, this is a review for chapter 2.5 when we were talking about i's for the first time and where we were solving quadratic equations for the first time. The first thing I'm going to go through is the simplifying standard for chapter 2.5, and that's these first 6 problems that you see here. So in question number 5, when you look at this, you should recognize that there's between the two parentheses, all we are doing is multiplying. So we're just going to FOIL together. So 2 times negative 7 is negative 14. 2 times I is plus 2i. Negative 3 times negative 7 would give us a positive 21, but there's an I. And negative 3i times I would be a minus 3i squared. One of the things that we need to remember from this chapter is that when you see an I squared equals negative 1. So I'm not done with number 5 and continue to combine like terms. So I have negative 14 plus 23i. And then this is minus 3, but I have an I squared. So that's times negative 1. So I have negative 14 plus 23i plus 3. Again, if I combine like terms, I have negative 11 plus 23i. So for this first question, as we simplify, we get negative 11 plus 23i. In question 6, you must recognize that you are subtracting. And before you can do anything, you should handle the subtraction possibly by distributing. So you get a negative 3 plus I, minus minus means plus 5, minus minus means plus 2i. And now this is all addition, so you just add like terms. So negative 3 and 5 is 2i, and 2i gives you plus 3i. 7, you recognize that you are adding. So it's just, again, you can get rid of the parentheses, because if I add them, nothing is going to change. So 2 and a negative 6 is a negative 4, negative 5i, and an I is a negative 4i. So part of this section was just combining like terms, but being very noticeable about multiplying, subtracting, and adding. The other part of the simplifying standard was simplifying square roots. When we simplified square roots, we thought of our perfect squares. So 48 is divisible by the perfect square of 16, and that goes in 3 times. The square root of 16 is 4, so I get 4 square root of 3. Square root of negative 9. Square root of 9, and you actually pop an I out, and the square root of 9 is 3, so I get 3i. Same thing with the square root of negative 90. The first thing I would do is pop an I out. Then I'm going to break apart 90 into the square root of 9 and the square root of 10. There's still an I there, and I get 3 square root of 10i. So that's how you do the simplifying standard for section or chapter 2.5. The remaining 2 questions are the solving standard for chapter 2.5. So let's look at those 2. We know that we have a quadratic equation. When you have a quadratic equation, you have 3 options to solve. 1, you could try graphing. Maybe the 2 solutions are really nice x-intercepts that are whole numbers. 2, you could try factoring. Maybe it factors really nicely and you can find your x-intercepts. Or 3, the method that always works is use the quadratic formula. Quadratic formula again is x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Since that's the method that always works, that's what I'm going to do in 11 and 12. A is 3, b is 8, c is negative 3, so x equals opposite of b plus or minus b squared minus 4ac all over 2a. And then I'm just combining and simplifying. So negative 8 plus or minus 64, 4 times 3 is 12, times 3 is 36, so plus 36 over 6, negative 8 plus or minus the square root of 100 over 6, So that's negative 8 plus or minus 10 over 6. Again, I'm not done. I need to separate that into my two solutions. So I have negative 8 plus 10 over 6, which is 2 over 6, or 1/3. And then I have negative 8 minus 10 over 6, which is negative 18 divided by 6, or negative 3. Those two solutions could have also found by, again, graphing or factoring. But again, quadratic always works. So I'm going to do that again with number 12. A is 4, B is negative 3, C is positive 3, X equals the opposite of B plus or minus B squared minus 4AC all over 2A. So I have 3 plus or minus the square root of, this is a positive 9, you're squaring a negative number, minus 4 times 4 is 16 times 3, so minus 48 over 8. So I have 3 plus or minus the square root of negative 39 over 8. The last thing I have to do is pop an I out. So I have 3 plus or minus the square root of 39I over 8. I can't simplify that any farther because 39 isn't divisible by any perfect squares. So that's my final answer. Again, those are the two standards that we saw in Chapter 2.5, simplifying and then solving quadratics using most of these methods. We did throw in the square root method, but that doesn't apply to either of these problems. If you have questions, please come in and see your teacher. Thank you.